In this episode, we're setting up our AI's ability to choose the right attack in the right situation. Hey guys, welcome to today's episode, and this is the second of a three-part series on AI spell attacking. So now that we got it set up such that the AI can aim using different kinds of abilities, now the question is, how does the AI decide when to use each ability? And luckily, this is a very simple question, at least for now, because our AI only has two possible attacks so far. So the key question is, when should our AI use our flamethrower versus our fireball? And the difference between those two is that the flamethrower is a short-range attack. It's very powerful, but it's only short range, and the fireball can fire really across the map. So what we're going to do is whenever a gameplay ability is spawned, we are going to set certain identifiers, basically a series of booleans on each gameplay ability that says this is a long range attack, this is a short range attack, this is a movement ability, and that list is going to expand with time. Like, can you use that ability when moving? And then with the gameplay ability pickup, the AI is going to add that ability to at least one array, but probably multiple arrays that correspond to each of those booleans. So for example, an array of short range abilities, an array of long range abilities, and that's going to then allow our AI to assess at any given moment in time, depending on the situation, okay, get an ability from this array and then use that ability. And this episode is just the beginning of setting up the logic for our AI to discern what types of abilities to use depending on the situation. And we're starting with attack abilities this episode, but I wholly anticipate that this is going to become much more advanced in the future. But there's no time like the present to start, so let's get to it. Alright, so we're going to start today by building off of everything that we set up last episode. So we'll go to our content drawer, and we got to go back to content core into AI and into our adversary AI controller. So not the character, but the actual controller. And the way we're going to start today is we're going to create those arrays I was just talking about. So we'll right click on gameplay ability hotbar and we will duplicate. And this first one I'm going to call short range attacks. And we'll right click on that and duplicate. Next one is long range attacks. And we'll right click on that, duplicate one more time. This one is going to be movement abilities. And we're not going to do anything with this episode, but just wait till the next. But now an ability can be more than one thing, right? So we want to create the capability of each ability being able to be added to multiple arrays. So for that, we got to go back to our content drawer, over to content, into our blueprints folder, into gameplay abilities. And for this, I'm going to put these all on the gameplay ability parent actor, so that way all of our child actors inherit all of these variables. So we'll open our parent. And we already started in our construction script last episode, the ability type and how gameplay ability is used. We're setting the speed multipliers, and we're going to build off of that same setup. So on the left under variables, this is where we're going to start creating our variables. So long range attack, and this is going to be a boolean, and another variable, we're going to do a short range attack, also a boolean, and last but not least, movement ability. And as you can imagine, we're going to take our long range attack and set it, and we're going to set it for the single cast, which is our fireball, and we're going to set that to be true. Move this in a little bit, and then we're going to do the same thing for our short range attack right below. Set, connect this up, make it true. And we don't need to set the variables that are false on each string because by default they're going to be false. And last but not least, our movement ability. So we can drag in, set, and check that off and connect it up. So we'll compile and save this, and now we have to determine, okay, based on these booleans that are being set when we pick up the gameplay ability, how do we add the gameplay ability to the appropriate array? So for that, we got to open up a third blueprint. So back to content, our core folder, AI, into BP adversary AI character. And I'm going to close out of these functions. Every single episode I open up way too many functions. We're going to close out of all of these. Back to the basics, back to the event graph. So on our event graph, if I zoom out, we're going to come over to our event pickup ability, attempt to pick up ability function. We'll go into that. And what I realized is that this is going to expand even further still, and it's already pretty messy. We have a lot of blue pins, a lot of lines, a lot of spaghetti being drawn all over the place. So let's start by making both of these into local variables. So we're going to move this over. We're going to right click on gameplay ability, promote to local variable, and we'll rename that, and that's going to be called our local, not loco, local gameplay ability. Connect this up, right click on gameplay ability pickup, same sort of thing, local variable. Connect this up, and once again, this is going to be local gameplay ability pickup. And we'll connect this up here. So what that then allows us to do is to take our local gameplay ability and get and connect it up, and we are going to start getting rid of all these pins. So we just got to follow the yellow brick road, actually the blue road in this case. So over here, we're going to take our local gameplay ability, drag it in, get, connect it up. Same thing right over here, local gameplay ability, drag it in, get, connect it up. delete out this one, delete out this one, and delete out this one. And I'll put in a little reroute right here. All right, so now we got our second one, gameplay ability pickup. And we'll come over here and we'll drag in a reference to our local, connect this up and connect it up right here as well. One last one. So over at our make array with tags, local gameplay ability pickup, get, and connect it up here. Delete out this, and delete out this. Zoom out. Yeah, a lot cleaner. Way easier to follow. That's the power of local variables. And the one last thing is I made a mistake here last episode. Up here in the gameplay ability intensity boost, I forgot to change the boost amount. So our gameplay abilities, when they're picked up a second, third, fourth time, they're not going to be boosted at all. So let's make this 10. All right, so the reason that we made local variables and we simplified this whole function is because now we need to make it more complicated. So in addition to adding it to our hotbar array, and even though our AI doesn't have a physical hotbar, it's still adding to that array. In addition to that, it's also going to add to other arrays. And it's going to do that after this pickup ability on hotbar. And I'm going to get rid of the attempt here. So it's just picking up ability on hotbar. But first it's going to do that. It's going to make sure that it actually is able to pick it up before it does anything else. But after it picks it up, what I'm going to do just to make this easier to follow is I'm going to add a sequence node. And that way what I can do is I can drag a pin down here and we're going to add another sequence node. And what I'll probably do is collapse the rest of this to functions. But once you already have everything collapsed to a function, as long as you can follow the logic as to what it's doing, that's really the important thing. So by doing a sequence to a sequence, I don't think there's any major performance implications to this, but it just means it's going to do this first, and it's not going to do this if it's taking this path up here. But it's going to do this path right here, and then it's going to come down and it's going to do this right here. All right, so why did I make this a sequence to a sequence? It's because we're going to take our three Boolean variables, long range, short range, movement ability, and this is going to increase with time. So over on our adversary AI character, this sequence is going to correspond to each one of those. So I'm going to add a pin, so we have three. I'm going to get the local gameplay ability that we're picking up, get, and I'm going to start with, is it a long range attack? So we're going to get that get long range attack variable, and then hook it up to a branch, and connect it up just like this, put in a reroute and then move it up. So if the gameplay ability that we're picking up is a long range attack, then it's true here. So what are we going to do? So in that case, we're going to get a reference to our AI controller, get AI controller reference. And which of these arrays are we going to add it to? Our long range attacks. So back to BP adversary AI character, we are going to get our long range attacks, get long range attacks, and then we are going to add to array. We can connect this up from the true to here, and what we're adding is our local gameplay ability. Connect this up, and I'll move down our sequence node just a little bit, create some space, but the rest of this is really simple. We just replicate it 2 other times. So paste that in and then paste that in again. So I'm going to connect up 1 to here, and then 2 down here. But for this, we got to switch these out. So instead of long range attack, local gameplay ability, we're going to check, is it a short range attack? And then connect it up. And over here, same kind of thing. So delete out our long range attacks. You might also need to delete out the add node, but let's see. So if we search for get short range attacks, yep, connect it up. Yep, we can do it. And last but not least, our unloved movement ability. So it will be loved in the long run. It'll be loved. Get, and then connect it up. Delete this out, move this in. Same thing over here. So delete that out, and we're going to get our movement abilities. Get movement abilities. Move this in, connect it up. All right, make sure you've updated all those variables. So 6 variables should be unique. So movement, short range, long range. And what I'm going to do, because this function is getting a little bit out of hand, we are going to take this entirety and we will right click and collapse to a function. And I'll right click on new function here, rename, and we're going to name it place ability in ability arrays. And we'll categorize that under gameplay abilities. But there's a problem with this function because these are grayed out. And the reason they're grayed out is because these are local variables from our other function, attempt to pick up ability here, and we haven't made them into local variables in this function. So let's do that. So we're going to take our purple node here. We'll do 2 inputs. First one is going to be gameplay ability, and it's going to be of type gameplay ability. You guys are going to know inputs and local variables really well by the end of this episode. And that's something that honestly didn't click with me for a long time, but once it clicks, then you could start utilizing them all over the place. It works really well. And we're going to take our gameplay ability. I'll make some space here, right click, promote to local variable. We're going to rename it exactly what we have here. So no spaces, local gameplay ability. And when you do that, it suddenly, ta-da, it recognizes it and it's going to work. So connect this up here and then connect this up here. And actually we just need one local variable. And the reason is that we don't need our gameplay ability pickup local variable. We don't need this one for this function. And just make sure if you look in this function that every single node is blue, it's recognized, everything looks good. You can compile and save. And when I compiled and saved, I got this error. And the reason I got this error is because we never compiled and saved on our adversary AI controller. So when you create new variables, you always need to compile and save after you created those variables. And then I can come back here, I can compile and save, and yep, voila, I was putting the cart before the horse. All right, so I think we're all set here, but we did forget one thing. Do you know what it is? So back in attempt to pick up ability, we got our place ability and ability arrays, but we never told it what gameplay ability to place. So I got to take our local gameplay ability from our parent function and connect it up here. And the parent function is this attempt to pick up ability. And last but not least, give it a comment for posterity. And this is going to be allows AI to discern different types of abilities. So we'll compile and save this. And now let's test shooting a short range versus a long range ability. So to start, we actually have to create a function for discerning which ability within each of these arrays to get, because we'll set up the capability of switching between the arrays based on the distance to its target, but it's a little bit more complicated than that, and this is more of a future thing. But in the future, we're going to have multiple short-range abilities, we're going to have multiple long-range abilities, and we need a mechanism by which our AI can get the appropriate one to use. Now for now, the simplest possible mechanism is which of them is strongest, and we can assess that based on the intensity variable that's in gameplay abilities. This is one of the first things that we set up all the way back in episode 26. So back in our adversary AI controller, we're going to create a brand new function. So plus sign here, we're going to call it get strongest ability in array. And because all this is doing is getting information, we can make it a pure function, and we're not updating anything on the abilities. And for this function, it's going to have two local variables. So our first one is local strongest intensity, and that's going to be a float. Basically, that's going to track in the function at any given moment in time, like what is that strongest intensity value of all the abilities in the array. And then the other local variable is going to be our local strongest gameplay ability. And that's going to be of type gameplay ability. Search up here. This one right here, object reference. And for our purple node here, we got to create a couple of inputs as well. This is our gameplay ability array. That is also going to be gameplay ability type, and it's going to be an object reference, and just right click on it. Actually, you don't right click, you just select the drop down and array. And actually that's the only input that we need. So we'll compile and save this, and then we'll take our gameplay ability array and we will for each loop connect this up here, because what we need to do is we need to say, okay, based on all the abilities in this array, go through each of them and figure out of all of them which is the strongest. And the first thing we're going to do is array element, we are going to check to see, is it valid? And we've done this before in previous episodes. So if it is valid, we got to compare two things. We got to compare whatever our local strongest intensity is now with whatever the intensity of this gameplay ability is. So get intensity, make a little bit of space, and we're going to check to see, okay, is the local strongest intensity less than this gameplay ability's intensity? Connect this up. Because keep in mind, this is going to start at 0. So by default, the first gameplay ability in the array, the intensity is going to be stronger than 0. So if that is true, we got a branch and then connect this up here. Because if this is true, then what we're going to do is we are going to update our local strongest intensity with the current gameplay ability's intensity. So we're going to take our array element intensity, so right here, connect this up here. But only if this gameplay ability's intensity is stronger than whatever's tracked already. So pretend we have two long-range abilities in this array. So let's say the first one has an intensity of 50, second one has an intensity of 100. So the first thing that's going to happen is it's going to get the first one and it's going to say, okay, is 0 less than 50? And the answer is going to be yes, and then it's going to say, okay, take the 50 and update the 0. And then it's going to go on to the second one in the array and it's going to say, okay, is 50 less than 100? Yes. So take the 100 and update it. But then let's say there's a third gameplay ability that has an intensity of 70. So in that case, it's not going to be stronger and it's not going to update. But if it does update, what we want to do is we want to take our local strongest gameplay ability and set that. And that's going to be set to whatever this one is right here. So connect this up here and I'll put in a couple of reroutes. So move this right over here, this one right over here. And so then when this loop is completed, that means it's run through all the abilities in the array. And from completed, we can add a return node. So add return node. And the return node, we are going to add an output. And the output is going to be our strongest gameplay ability. Strongest gameplay ability. And that's not going to be an array. It's going to be a single. So we're going to take our local strongest gameplay ability here, get, and connect that up. And I'm just going to clean this up a little bit. Try not to cross the streams. Compile and save this. So now we have a function on our adversary AI controller for getting the strongest ability in the array. And now we can reference those functions when we want to test this. And we want to test it right now. So let's go back to our third-person character blueprint. So BP third-person character. So we'll need to actually play an editor in order to test this. So if I zoom out on the event graph, so last episode we set up keyboard U up here, and we're going to do the same exact thing we've got here, but what I'm going to do is copy all of this, and all this is temporary. This is all for testing. Paste this down here, but this is complicated, so we got to do thorough testing. All right, so we're going to right-click, and we're going to do a keyboard O now. Got to scroll down to O. When pressed, connect this up, and it's going to be very similar, but the only thing we're going to change here is instead of gameplay ability hotbar and getting the array element 0, what we're going to do is from AI controller reference, we're going to get our long range attacks. And instead of this, so we could delete this out, we are going to get strongest ability in array. And if you don't see this, what you got to do is you got to take your AI controller reference here and search for get strongest ability in array, and then you should see it. So connect it up like that. I'll delete this one out, and we'll connect up our array just there. And let me clean this up a little bit. So we could delete out our gameplay ability hotbar. I'm going to move our AI controller reference right there. I'm going to move long range attacks right underneath it, and get strongest ability array I'm going to do right there. Actually, let's make a little bit more space. Connect it up right here. And I'll add in a reroute right here and connect this up to the target up there as well. And delete out this pin. I would clean this up even further, but this is just temporary, just for testing. So make sure on keyboard O, really whatever keyboard you want, it's doing this. Because it's still going to act as a toggle. It's still going to deactivate if it's on and activate if it's off. But all we're doing now is we're testing, okay, is it able to get our long range attack? And then we also need to replicate this for short range attacks. So I'm going to copy all of this. We're going to paste it down below, and we're going to use keyboard P. So between the two of these abilities, they're OP. Is that it? Man, my jokes are getting lamer as I age. Okay, the next thing we got to do is we got to update long range attacks here, and we got to get instead short range attacks. And that's the beauty of this function, get strongest ability in array, because it doesn't matter what type of attack we're using. We're just passing in the array, and then it gets the strongest ability in that array. So compile and save this, and make sure you've got that for both O and P or whatever keyboard buttons you choose. And the next thing we got to do is we got to set up our AI's ability just here in our third-person character to be able to pick up multiple abilities. Because if you remember, last episode we set up Y here, and Y just picks up the ability. But the problem is it's going to keep trying to pick up that same ability even when it goes inactive. So what I'm going to do, just temporarily, we are going to get our gameplay ability pickup, and we are going to destroy the actor. This is not going to be how it works long-term. But by destroying the actor, this way we can ensure, okay, if we have two abilities, AI will pick up the first one, it'll be destroyed, and then they'll pick up the second one. All right, compile and save this. We are really close to being able to test. So we'll minimize this, and then we'll duplicate our ability here. This one, we're going to switch over to our fireball pickup. Fireball icon, doesn't really matter for our AI, but that's fine. Fireball with UP. And how gameplay ability is used is single cast. All right, right click, play from here. So the way this should work is we hit Y, picks up our first ability. So far, so good. Y again picks up the second ability. We got to wait to make sure our AI is actually looking at us. And once it's looking at us, then O. Yeah. O, P. What about P? Don't forget about P. Okay, there's our flamethrower. P again, flamethrower's off. So far, so good. So we know our two arrays are working. So now we have to set up the logic to discern, okay, when does our AI use short range attacks versus long range attacks? So there's a couple of quick things we got to start with on our adversary AI controller here. So back in our event graph. So the first one is we're just going to take aggression here. So on target perception updated AI perception site, we're going to take aggression from the switch on AI mode that we set up last episode. We're going to hook that up to this branch because basically aggression is going to correlate is our player seen. And in the future, AI characters might be able to fight with one another, but we're going to cross that bridge when we get there. And while I'm here on the adversary AI controller, I'm also going to increase the range of AI perception sites. So we're going to select that, and on the right-hand side, site radius, we're going to set this to 10,000. So our AI can see all the way across the map, lose site radius 12,000. And then compile and save. All right, so over to our adversary AI character. We're going to go back to the event graph, but actually we're going to create a brand new function. So way back when we started our AI, we set up this set timer by function named jump and movement check, where every 0.3 seconds it's checking to see should our AI jump, should it move, etc. And we're going to do something very similar for attacking, but it's going to be on a separate timer than this. So in order to do that, we need to set up an attacking function. So under functions here, plus sign, and we're going to name this simply attack check. And the first thing attack check is going to do is it's going to check to see, okay, our AI controller is our short-term mode aggression. So short-term mode, and we'll check to see if it's equal enum, if it's equal to aggression. And then from that we'll branch, connect this up. And then we need to check to see, okay, do we already have an activated gameplay ability? Because if we already have an activated gameplay ability, like if it's already in process of casting a spell, meaning it's in that in-between time when it can't be activated or deactivated, then we might as well just stop this function because there's nothing else that it's going to do until it gets called the next time. So I can right click and we're going to search for our activated gameplay ability, and this is a variable on our third person character. And I'm going to right click on this and I'm going to convert it to a validated get, and that's going to tell us whether or not we have an activated gameplay ability. So for our activated gameplay ability, is it able to be activated or deactivated? So that's a Boolean. And so if this is valid, if we do have an activated gameplay ability, then it's going to assess this. So we'll branch from here and we'll connect this up. And then only if this is true will it go further. And then if our activated gameplay ability is not valid, meaning we don't have an activated gameplay ability, well, we can keep going in that case too. But the next check we're going to have is we're going to check our current target. So current target car. And this is not that our current target is a character, it's that it's our current target variable on our character here. I need to figure out what to rename this such that it's clear what this is doing. But what we need to do now is we need to verify, okay, is our current target an actual character? So in order to do that, we are going to cast to BP third person character. Because if our target's like a pickup actor, it's not going to attack the pickup. So anyway, so cast a BP third person character, we can convert this to a pure cast because we're not changing anything. Because if we're able to successfully cast to it, then we know our target is a character. So that's another check there. So we'll connect true up here. We'll connect is not valid here. And actually, I'm just going to move all these in a little bit, something like that. And all of this, it's doing 3 separate checks. So what I'm going to do, I'm going to move out attack check, and we're just going to comment all of these. And then for the comment, so let's see how fast I can type here. So the first check is checking whether or not we're in aggression mode. The second is if we have an activated gameplay ability already, then check to make sure that activated gameplay ability is able to be deactivated. And then number 3, that our current target is a character, and it only proceeds if all 3 are true. And so now we get to the main event, right? We're at the point at the end of this chain where we are ready to activate a gameplay ability if one's not already active. But now we need to determine, okay, which gameplay ability are we going to activate? And we already talked about this, that it's going to be based on our distance to the target. And we could do this really simply, right? We could just get our current target's location, the character's current location, compare that, and then figure out, okay, beyond a certain threshold, use long range, and less than this threshold, use short range. But it's a little bit more complicated than that if we want to do this properly. And that's because, and we already talked about this last episode, we want to consider where our target's going to be when our gameplay ability would actually reach that target. So let me give you a scenario. So let's say our target is currently running straight at our AI character, right? So where the target's going to be in 1 or 2 seconds when our character can actually shoot at it is going to be different than where it is now. So it could be like 10 meters away, but in 2 seconds, it could be 5 meters away or less. And our AI character needs to anticipate where it's going to be to intelligently aim and therefore intelligently select the right ability. But luckily, we've already done all the heavy lifting to figure out where our target's going to be in that certain amount of time. And we did that last episode with the aiming. So what we're going to do is we're going to go back to our content drawer. We're going to open up, not under AI, not this guy, because we're retargeting our animation blueprint. So we're going to go back to our core folder, ABP third person character. And we have to go back to the assess adjust aim function that we messed with last episode. And what I'm going to do, I'm just going to move all of these out a little bit because what we're going to copy is everything from current target down here, all of this, except for get world location and character. So I can hold control, unselect those. We're going to get all of this stuff because this pin, this right here, this is where our target will be. And it's calculating that based on the speed multiplier of our gameplay ability. Now, before we cast a gameplay ability, we're not going to know what our speed multiplier should be because we're not going to know which gameplay ability we should use. But we're going to talk about that. So for now, let's just copy all of these. So right click copy, and we'll go back to our adversary AI character, and I'll come down underneath this function. So down here, paste, and I'll move all of this in. And what I'm going to do is I'm simply going to replace this current target reference with our current target car here. So we're going to take that and we are going to get connected up here. And same thing right over here, get connected up there. And last but not least with get velocity. So current target car and connected up here. And we can delete this one out. And we still have to clean up this right here, so we can delete out our third person character, and instead we're just going to get a reference to ourself. But actually we don't need to because it's already doing that. But now I just mentioned this, we can't determine what our speed multiplier should be because we don't have a gameplay ability active yet. And I was trying to think about this pragmatically because let's say our character's target is running away. If our AI overestimates where its target is going to be in like 1 or 2 seconds, I think that's okay because it recalibrates its fireball. It's going to use the fireball, it's going to use a long range attack in that case, and it's going to recalibrate our fireball based on when that fireball is released based on our target's current velocity and position. But with the flamethrower, we want to make sure that the AI character will use the flamethrower in the proper circumstances. I'm worried about that situation in which the target's running very fast at our AI character and it doesn't realize that it's going to be so close that it should be using the flamethrower. And so because of that, I'm going to treat this like the flamethrower rather than the fireball. I think the fireball will take care of itself, but the flamethrower, I really want to make sure that it's used under the right circumstances. So we're going to keep this to a speed multiplier of 1, at least for now. So I'm going to drag these out and we'll just do a comment on these. And in the comment, I'll just say, may need to change this multiplier in the future. Right now set to 1.0 for proper anticipatory aiming. And like we did a few episodes ago with something that we're probably going to change in the future, or at least we may change in the future, I'm just going to change the color of this comment. All right, so now we're all set with the starting point of this. So this right here, this node is where our AI character's target is going to be. And so now we need to compare this with where our AI character actually is. And we need to figure out, okay, what is the range of that? And is it beyond a certain threshold or within a certain threshold, and switch long range versus short range accordingly. So in order to compare this to our AI character's location, we are going to get actor location, and that's our AI character. And then we're simply going to get the distance. So distance vector, and compare these 2 points. And then we need to set a threshold. So if this is less, and I'm going to set this threshold to 500, so 5 meters. But if this distance is less than 5 meters, then we're going to branch. We'll connect up the true here, and I'll move this in a little bit, because what I'm going to do is I'm going to take all this logic, move it underneath. And this also might change. I might change this threshold from like 5 meters to 7 meters, something like that. So we're also going to do a comment here. And this comment's going to be threshold for long range versus short range attacks. May need to change this in the future for proper anticipatory aiming. So we will make this red. All comes down to testing, guys. All right, so now we come up here, and this is our key branch that's going to determine if true, then it's less than 500, then it's going to use a short range ability. If false, then it's going to use a long range ability. But once again, it's more complicated than that, because this function is going to be called like every 0.2 seconds, something like that. And let's say our AI character already has a flamethrower up and running. It's already shooting the flamethrower. So every 0.2 seconds, it's going to assess, okay, is its current target still within the range of that flamethrower? So we first need to check with each of these, do we have an activated gameplay ability? So once again, we got to get a reference to get activated gameplay ability. And I got to turn this into a validated get. True is going to be connected up here. And we're going to replicate most of what we're going to do also for the false branch, but let's just set it up for true here. So we said for true, we're assessing the short range attacks, so we're getting our AI controller reference, and we are getting our short range attacks. And then from our AI controller reference, we can get the strongest ability in array, and we can connect up our short range attacks. And actually, I'm going to add a reroute here. I'm going to move this over here, move the reroute up a little bit. So now, if we already have an activated gameplay ability, it's going to do that. And what we need to do is we need to compare. We need to say, okay, is our activated gameplay ability the same as our strongest ability in array? Is it already using the strongest ability? Because if it's already using it, then what do we need to do? Nothing, right? Because it's already casting the flamethrower in that case. So it's only if this is false. Like, let's say it's using a channeled ability, but not its strongest ability. Then we want to deactivate the ability. But in order to deactivate, I got to get a reference to activated gameplay ability here, and we're going to call the assess deactivate ability function, and then connect up false to it. And there are other reasons why we might want to deactivate the ability. So for example, let's say our AI character can't turn all the way around to actually hit its target. Then we want to deactivate, allow it to rotate. And we'll get to all that, but let's just finish this out. So let's put in a reroute here, move this down. And if we don't have an activated gameplay ability currently, that's where we're taking our strongest ability in the array. And from this, we are assessing, can we activate? Assess activate ability. And then connect up is not valid right here. Double click on this, create a reroute, and we'll do the same thing over here. So now we got everything for our short range attacks. And what I'm going to do is I'm going to copy all of this, paste it down below, connect up our false down here, because this is then what we're going to do for long range attacks, except we're just going to switch out our array. So from AI controller reference, we're going to do long range attacks. Connect this up here, delete this one out. So we'll compile and save this, and then back in our event graph for our adversary AI character, well, let me zoom out. We just did a whole bunch of blueprint logic, so just make sure you've got everything. Looks like this for short range, looks like this for long range. Over here on the left. So now we need to actually call this function on begin play, and we're going to loop it to start, and we're going to set it to loop. I found what works best to be about 0.2 seconds. So on the same stream on begin play, back in our event graph, so at the same place where we did jump and movement check every 0.3 seconds, just going to move this out, make some more space, copy this, paste it over, connect this up. We are going to do an attack check. and then connect this up here. And this one's going to be 0.2 seconds. Just make sure that the name here, function name, matches verbatim. This one right here. No spaces. Remember my beef with spaces and function names. All right, compile and save our adversary AI character. And then we have to trigger this. So back over to third person character. Remember, the first check on our adversary AI character's function is checking to see whether or not our character is currently in aggression mode. And if I go over there, back to attack check. So that's this mode right here. So on our third person character, when we actually test this, when we play, we need to switch our AI over to aggression mode. So I'm going to zoom out and we're going to create another shortcut. So I'm going to copy our BP adversary AI here, paste it down below. We are going to do keyboard X. So Y is going to pick up ability and X is going to then switch them over to aggression. So get actor of class, and then from here, we are going to get our AI controller, get AI controller reference, and then from this we are going to set the short-term mode. Set short-term mode. Connect this up, and this is going to be aggression. All right, compile and save, and we are ready to test this out. All right, we start with picking up abilities. Y. Second ability, Y. Now, establish contact. Make sure he's actually looking at you before you activate X. You might need to run around a little bit. Make sure he's turned to face you, just like that. And then once you do that, X. And he should immediately start attacking. But then the thing to check is run at your target. And there's the flamethrower. But it's still not great, right? Because I can sort of get behind him and he can't, well, he's kind of gets me. He turns a little bit and tries again. But I can sort of exploit this, right? You ever play a game where you just find an exploit with an AI character and you could just, something cheesy like this where, you know, it's not intended how the game's supposed to be played. So let's see what we can do to fix this exploit. So we got to go back to our BP adversary AI character, and we got to go back into the attack check function. And to fix this exploit, we can do something very similar to what we did last episode, which is we can simply check, okay, is our target within a 180-degree arc in front of our character? So basically it's looking at negative 90 degrees and positive 90 degrees, anything in that vicinity, then it's going to attack. So if we zoom in here, so we can add a branch node between these two branches. So a branch here, and I'm going to zoom out again a little bit because I'm going to move all of these down slightly. And these three nodes in the comment, I'm just going to pivot slightly. So I'm going to move them down, and this one move down here. And now we're going to do something a little bit simpler than what we did back in our animation blueprint last episode. So this find look at rotation, instead of that, what we're going to do is use a find relative rotation node. And what that's going to do is it's going to measure the rotation of our capsule component and where our target is, and it's going to compare, it's going to do a relative rotation and see if that's within an absolute 90 degrees. So back in our adversary AI character, so we can right click here, we can search for find relative look at location. And we need a starting transform. So what I'm going to do is I'm going to get our capsule component, and then we are going to get the world transform. This one right here. I can connect this up here, and then the target location is right here. And that's going to give us our rotation. But again, just like last episode, all we're focused on is the Z. So I split the struct pin, and then we're looking at the absolute value of that Z because it could be negative 90 or positive 90. And if that absolute value is less than 90 degrees, so 90 here, then we'll come up here and connect this up to the branch. And I'm just going to reposition these slightly. I'm going to put this up here. So we'll compile and save this. And there's one other change that I'm going to make. And this is just due to trial and error. I was testing, could I still sneak behind the AI character? And I found that I could. And the reason is that the AI character was kind of locked to a slow rotation. And that was the Z equals 180 that we set up 2 episodes ago. So if we come down in our adversary AI character, the character movement, and then we look for rotation. So this rotation rate right here. So this 180. So if we up this, I'm going to up this so that the AI character can rotate 4 times as fast. So we're going to change that rotation rate to 720. And the last thing we're going to do here is if this rotation is actually greater than 90, so if our target is outside of that arc, then what I'm going to do here is I'm just going to set it to use our fireball down here. And the reason we're going to do that is that's going to give the AI behavior a sense of randomness. Like sometimes if you're trying to rotate around it, it's going to use the fireball even at short range. And the nice thing about the fireball ability is it's a little bit more flexible because the AI is still moving. So in that half a second that it takes to actually cast the fireball, it could rotate a little bit more, and then it can rotate further using the spine rotation. So with those 3 things, so with this check here, with connecting this up to fireball so that it still actually fires an ability and making our AI rotate a lot faster, you're going to see it's going to be a lot more dangerous. Let's compile and save, and we'll test this again. Our AI has both abilities. So now wait till it reestablishes contact, X. I can get around it, but it's still casting fireballs here. Yep. so the AI's attacks feel a lot less predictable at short range. But there's still one more issue that we need to solve, and you're only going to see this at long range where you can actually hide, get out of line of sight from our AI. But this is a good thing to test generally. Can your AI still see you and shoot at you from a really long range? Now, obviously, I can more easily dodge the fireballs from this range. But let's talk about the issue I actually want to solve, which is if I get below the ridge, so the AI can't actually see me, but it's still firing fireballs. But let's fix this, right? Because if our player character is out of line of sight, we don't want the AI still firing fireballs. So to fix this, we can use a function that we already have. We created this function all the way back in episode 49. So if we go under AI movement, we've got the target line of sight check right here. We can open that up. And all we need to do for this function is we need to add a return node to it. So if I come to the end of this function right here and drag out a pin, we could search for return, add return node. And in the details panel, what we can do is expand our outputs here and add an output. And the output we're going to add is has line of sight with a question mark, and that's going to be a Boolean. And in this case, if we're continuing line of sight, check, has line of sight. But in the false branch, this is where we're going to duplicate our return node. We're going to uncheck this and then false connect it up right here. Because what this is doing is it's doing a line trace to our current target and seeing if it hits it. Now, if it does hit it, then we've got line of sight. It continues line of sight and check. But if it doesn't hit it, then it doesn't have line of sight. That's what it'll return. And then all we need to do, I'm just going to compile and save this, and we can go right back into our attack check function. And I'm going to go all the way to the front of this, because what I'm going to do, I'm just going to expand this a little bit more. And this part down here, this is actually going to be one of two things that need to be met. So we're going to do an and Boolean. Connect this up, and actually I'm going to connect it down here, hold alt, disconnect the top one, move these three down, because what we're going to do is before the attack check, we're going to call that function. We're going to call the target line of sight check. And because we added that return node with our Boolean variable, has line of sight, only if that's true, and our AI controller is in aggression mode, then it's going to proceed forward. And I'm just going to add to the comment up here, checks to see has line of sight in aggression mode. Move these up, clean it up. So we can compile and save again, and once again, we could hide on our hill, see if it's attacking. Reestablish contact, hit X, and it should be firing as long as it's in line of sight. And you get behind the hill, oh, he stopped attacking. If I get within line of sight again, back to attacking. So the last issue I see, and really this is just my aversion to robotic behavior in AIs. Any AI that's predictable, it just instantly bothers me, right? It's just this instant flag in your mind that it just feels off. I'm fighting a robot or I'm talking to a robot. It's not real. And that is the fact that our AI is just attacking every 0.2 seconds, right? It's robotic, it's regular, it's standard, boom, 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 boom. So why couldn't we vary that up a little bit? Like why couldn't we just randomize it slightly? So it's anywhere from like 0.1 seconds to 0.4 seconds. And I think that'll give enough of an edge to make the AI feel a little bit more organic. So what we're going to do to fix that, if I go back to my adversary AI character into the event graph. So instead of looping here, what we're going to do is we're going to uncheck this. We're going to go into our attack check function. And then all I'm going to do is with this purple right here, we are going to add a sequence node. I've been using a lot of these lately, but sequence, it's just really nifty, really easy way of separating out parts of a function. And then all I'm going to do, actually, I'm going to zoom out a little bit, move this out. All I'm going to do is right here with the one, we are going to do a set timer by function name. So first it does all of this, and then anywhere from, let's do a random range and float. So anywhere from 0.1 to 0.5 seconds later, then it's going to call this function again. And to make sure I get it verbatim, you know how this goes. I'm just going to right click, rename, copy, and paste it in the function name right there. And no need to check looping because this is just going to call itself every 0.1 to 0.5 seconds. And this is a very weird thing that I found, but unless I put in the attack check first and then did the random float and range, so if I did this first and then put in the function name of attack check, then it didn't work. So just make sure always to put your function name first and then connect up the random float and range. And the other thing you can do is once you begin simulating, you can set this to be your BP adversary AI character and just watch to check to make sure that attack check is repeated over and over. So once it has a target, let's see if it's somewhat randomized. Yep. It's still pretty regular because it's only 0.1 to 0.5 seconds, but sometimes there's just that extra pause. Gives it a more organic feel. So as we always do, we're going to end the episode by cleaning stuff up. So over to our attack check function. Just going to zoom out, come over here on the right-hand side. We're going to take everything from get strongest ability over to here, and we are going to collapse this all to a function. And the reason we're going to do that is because we're basically doing the same thing down here. We're just passing in a different array for each one, long range versus short range. So right click, collapse to function. Move this in just like this. And we're going to right click over here. We're going to rename. We're going to name it AI strongest ability activate check. And then we'll go into that function and we just want to change a couple of things. So I'm going to move it over to start. And the other thing I'm going to do is we can get rid of the self2 here. We don't even need that. So I'm going to X out of that. And what we can do instead is get our AI controller reference, get connected up right here. And compile and save, you'll get an error, but then we'll fix it. So we'll go back to the attack check function and we can disconnect our AI controller reference there, and that's going to solve our error. And then what we can do is take that same exact function, copy it, paste it. We can delete out everything here, move it in here, connect this up, move this up a little bit, and connect this up here. And I'm going to move this one in. So compile and save this. And we should do one last test, but I feel like we've done a lot of tests. Let's do something different, huh? So let's take our gameplay ability pickup actor. Let's duplicate one of these, and let's switch this over to our air ability. Let's run around with a speed boost. So I'm going to switch this over to cloud, small cloud base. Our ability icon is going to be air. Come all the way up to the top, air ability channel icon. Ability type is air. Ability primary Niagara system is going to be our air channel with UP. And how gameplay ability used, instead of single cast, channel. And then right click, play from here. And make sure to pick up the air ability first. And that way it's going to be labeled inert and our AI character won't try to pick it up. So Y. Got two different abilities. Reestablish contact. All right, he's got us. So now I'm going to full screen this just for fun. And X. And 1. All right, try to hit me now. Oh, he's still hitting me. And he can even aim at me when I'm floating in air. How's that? So one very last update I'd like to make, and this is in our adversary AI character on the attack check function. What I was thinking was two things. So number one, our AI character might not have any short range attacks or long range attacks at any given moment in time. So we really should, under the AI strongest ability activate check function, we should add an is valid check here. And the second thing is, so back in the attack check, let's say the AI doesn't have any short range attacks, but it does have a long range attack. So even if the character, even if its target is within short range, it could still use a long range attack. Not the other way around though, right? So it can't use a short range attack for a target that's out of range. So we're going to address both of those with a very simple update. So AI strongest ability activate check, we'll go into that. The strongest ability in array, we're just going to do an is valid check right here. Connect this up here, connect this up here. And then following this node, we are going to add a return node. Done this many times. And the return node is going to have an output. So we're going to call this output no ability in array. And we're going to keep that a Boolean. So in this case, it is valid. So we do have an ability in array. So this is going to be false. But now we're going to duplicate the return node, put it down here, connect up is not valid. And this one, yes, no ability in array. So compile and save this. And then over in our attack check function, now our function has a no ability in array output. And so what I'm going to do here is for our short range attack. So if we don't have a short range attack, I can just move this out. And if there's no ability in the array, meaning this is true, then what we're going to do is connect this up just like this. Now for long range attacks, if we don't have any ability in that array, well, we can't do anything anyway. So we'll just leave that as is. Compile and save. So that concludes our episode for today. In our next episode, fair warning, it's going to be a long one, but I think you're going to find it worthwhile. So I hope to see you there next episode.